In this video, I'm going to show you how to run a Windows virtual machine within CML, or as it was called, Cisco VIRL 2. A common misconception about Cisco Modeling Labs, or VIRL, once again as it was called, is that you could only run Cisco devices or appliances on CML. That's not true. It actually comes bundled with some Linux devices such as an Ubuntu PC. So if you want to test network automation and network programmability, you have a built-in Ubuntu PC that you can add to your topologies. It also has some Alpine Linux devices that you can add to your topology. So it does support multi-vendor environments. So when I was discussing this video with the VIRL developers or CML developers, Ralph and Simon, I said it would be great to demonstrate Windows 10 running within CML. And Ralph helped me set this up because it's a fairly complicated process. So VIRL or CML is very, very simple to get started. Very simple to add Cisco devices to your network, add a Linux device to your network. But it becomes more complicated with other virtual machines, such as a Windows virtual machine. Typically, when you download a virtual machine from Microsoft or somewhere else, you're going to get an OVA. And that OVA can be imported into VMware Workstation as an example, or into VirtualBox or other virtualization software. Now CML requires a QCOW2 file or QCOW file. So you have to go through various steps such as downloading the OVA, you have to download QEMU, you have to extract the vmdk file from the OVA, you have to convert that vmdk file to a QCOW2 file, you have to use SCP to copy it to VIRL. Then you have to create this template within VIRL using that QCOW2 file, and only then can you import it into your topology. So I'd say this is one of the more complicated things to do in VIRL, but what I've done is I've created a whole PowerPoint presentation which you can download. So I'm showing you step by step using the commands that I'm using in this video, how to get this working within CML. So simply download this presentation. I've put a link below this video where you can download it. Download this and follow the steps. But I'm going to show you now through a video how to get a Windows 10 virtual machine running within CML or Cisco VIRL. Now in this example, I'm running CML or VIRL 2 on my Mac within VMware Fusion. I'm using a pre-release version of the software. It hasn't been released yet at the time of this recording, so hence mine is still called VIRL 2. They recently changed the name to CML, so when you get a public release of the software, it'll say CML 2 rather than VIRL 2. But the virtual machine is running on my Mac. But I'm going to show you how to download the OVA, how to convert it, and do all the steps using a Windows laptop. Because most people use Windows, I want to demonstrate this using a Windows computer. So I'm going to show you how to download the OVA from Microsoft, how to extract the vmdk file, how to convert the vmdk file to a QCOW2 file using a Windows laptop, how to copy it to Cisco VIRL or CML using secure copy, and then I'll show you through the GUI of CML how to add this virtual machine to your topologies. So whether you're running VIRL on a Windows laptop or on a Mac or on a Linux computer or in the cloud, process is very much the same. QEMU allows you to convert files on a Windows computer, Mac, or on Linux. Very similar commands will be used, but I'm going to show you how to do this on Windows, just because most people use Windows computers. The first step is to download an OVA from Microsoft or use an OVA that you've got already. I've got two links here, one to the Microsoft Edge virtual machine that you can download, or a Win 10 virtual machine. The Edge virtual machine is a lot smaller. Now it's still big, you're looking at 10 gig, but the second one is 20 gigs, so you may prefer using the smaller image. Now it depends what you're doing, but I don't typically need the latest version of Windows in a VIRL lab or CML lab. I simply want a Windows computer to test connectivity and test some basic stuff. But obviously, if you want to test something specific to Microsoft, you may want to download the latest version of Windows. You also need to download QEMU. So I've put the download links in this PowerPoint presentation. We then need to unzip the zip file that we get from Microsoft. We need to open up a command prompt and navigate to where the vmdk file is. In this example, I'm using Windows, so we're going to open up a command prompt. On other operating systems, you would open up a terminal as an example, and then we're going to use a command like this to convert the vmdk file to QCOW2 file. Again, you need to upload a QCOW2 file to CML, otherwise it won't work. It won't accept an OVA file or vmdk file. It needs to be QCOW2, so you need to do this conversion. And then you need to use secure copy to copy it to the CML server. So change this IP address to the IP address of your CML server, change this to the name of your administrator account, so the web UI admin account, and change this to the name of the QCOW2 file that you're uploading. So we're going to use secure copy. We're going to copy the QCOW2 file that we created in the previous step using this conversion command. So whatever you've called this file is what you're going to upload to the CML server. So change this IP address to the IP address of the CML server that you're using. This is your web UI or your web interface administrator account. So change that to whatever username you used for your admin account. And then we need to create some node definitions. I'm going to go through that in more detail in the video, but once again, I've put this kind of information in this PowerPoint presentation so that you can keep this as a reference if you want to add other virtual machines from other vendors to CML. Okay, so on my Windows computer, first thing I'm going to do is go to bit.ly and specify Win10 OVA Edge. That'll redirect me to the Microsoft website where I can download various virtual machines where I can test IE11 and Microsoft Edge Legacy. Once again, if you want a more modern version of Windows, then use this bit.ly link Win10 OVA, and that allows you to download a Windows 10 Enterprise version of Windows 10. This will be a lot later, a lot more current version of Windows 10. The problem, however, is this is 20 gig, whereas this file is a lot smaller. So I'm going to download the Microsoft Edge version, and I'm going to download that for VMware. I'm going to save that to my downloads directory. That's 6.7 gig in size. Now it's going to take about an hour to download this. So what I'm going to do is I'm going to cancel the download and I'm going to use the version that I've already downloaded. So notice here's my MS Edge Win10 VMware zip file. I downloaded this in preparation for this video. I've also got a Win 2003 developer evaluation VMware zip file, but notice this is 19 gig in size. Once you've got your Microsoft OVA downloaded, you need to download QEMU. So in my browser, I'm going to go to qemu.org, go to download, select the version for your operating system. In this example, I'm once again using Windows, so I'm going to download the Windows version. In my example, I'm using a 64-bit version of Windows. So if I have a look at my PC, I can see that I'm using Windows 10 64-bit operating system. So in other words, I need to download the 64-bit version for Windows. Most of us are probably using 64-bit Windows today, but if you've got an older version of Windows, you would download the 32-bit version. You need to download the executable, so the QEMU installer for Windows. So I'm going to click on that file and then save the file to my local computer. So the file is about 129 meg in size. In preparation for this video, I actually previously downloaded this file. Internet bandwidth has been really poor, especially during this lockdown here in South Africa. So I pre-downloaded a bunch of stuff to get it ready for this video. But basically all you need to do now is wait for that software to download and then you can install it. Okay, so this is the file that was downloaded. Both of these files are exactly the same, but I'll use the version that I downloaded right now. So I'll double click on the file. Windows complains that this is a application that was downloaded from the internet. I'm going to click install anyway. I'm going to allow the app from an unknown publisher to make changes to my computer. I'm going to say yes to install it. The installation of QEMU is fairly simple. I'm going to select my language of English and click OK. Click Next to start the wizard. QEMU is licensed under the GNU General Public License, so make sure that you're happy with that license and then click I agree. I'm going to stay with the defaults, so all these components will be installed. Click Next. I'm going to use the default installation folder. Now just note your directory. We are going to run QEMU and do a conversion. I'm assuming in this example that we're using the default directory. So if you do change the directory, then make sure that you change the path in this command. But I'll stay with the default and click install. QEMU is now installed. Basically, that's it. That's how you install QEMU. You go through some basic options and then you just need to wait for the software to install. So it's busy installing a bunch of stuff. And there you go. QEMU is now installed. I'm going to click Finish. So just to reiterate, QEMU, in my example, has been installed in C, Program Files, QEMU, and the application that we're going to run is QEMU image. That's the application that's going to do the conversion of a vmdk file to a QCOW2 file. So that's the application that we're going to reference with our command. The command, once again, to do the conversion is this. I'll show you that in a moment. But firstly, we need to uncompress the zip file that we downloaded from Microsoft, or open the OVA that you've already got downloaded. So I'm not going to use this 2003 EVE-NG Windows version because it's so big. It's 19 gig or so. I'm going to use this MS-EDGE Win10 zip file, and I'm going to unzip it to the local directory. So essentially, I'm just unzipping it to the downloads directory. So here's the zip file, and here's the folder that's been extracted. We've got a subfolder, and inside there we've got a vmdk file. Now at the moment it's 0k because the file is still extracting. So you need to wait for the file to extract. But once it's extracted, you can run this QEMU command to convert the vmdk file to a QCOW2 file. Okay, so the extraction has completed. Here's the command once again that we're going to use to convert this vmdk file to a QCOW2 file. We're going to use the QEMU image file in C Program Files QEMU. We're going to convert the MS-EDGE Win10 VMware Disk 1 VMDK, in other words, this file, to a QCOW2 file with the name Win10 QCOW2. Now, you could use a different name than Win10 QCOW, but make sure that this name matches the VMDK file that you've extracted. In this example, I'm going to compress the file because it's already quite large. It's 7 gig, so I want to make it smaller. If you don't do that, your file will be very large. And we want to see the progress of the conversion. We're once again converting this to a QCOW2 file. So I'm going to copy that command, and I'm going to open up a command prompt. So cmd prompt. What I'm going to do is navigate to this directory. So cd downloads, cd MS-EDGE VMware, cd MS-EDGE Win10 VMware, dir shows us the files in this directory. So again, this is the file that we want to convert. I'll clear the screen to make it easier to read. But notice dir once again shows us the file that's going to be converted. And the command once again is this command that converts that file to a QCOW2 file. I'll just make this window a bit smaller so we can see the output better. At the moment, you can see that it's converted 0% out of 100%. I'm going to speed the video up at this point because it takes quite a long time to do the conversion. So I'm not going to bore you showing you that conversion. So basically, we just need to wait for this conversion to take place. So I'll speed the video up. Now, this is really important. Before you upload a Windows image to your VIRL server, you've got to make sure that you have enough disk space or storage space. Typically, when you import the VIRL OVA, it's only going to allocate a 16 gig disk. So the disk is too small. We're going to want to make this disk a lot bigger because the Windows images are very large and it'll consume all the disk space on your VIRL server. So to do that, I'm going to go to the web UI. So IP address of VIRL server, log in with my username and my password. Now at the moment, notice my disk space is okay. I've got 13 gig left, but when I upload that QCOW2 file, it's going to consume all my disk space. Trust me, I've done this. I've fallen into this trap and had problems. So we definitely want to increase the disk space quite a lot. So I'm going to go to Tools, System Administration, and notice I can run what they call the cockpit service, which runs independently of the VIRL 2 platform and allows for recovery in case there's a problem. You basically point to the IP address of your VIRL or CML server and use port 9090. So port 9090, and then you log in with your CLI username, not your admin or web GUI username. So this is my CLI username. Make sure that you select this option, reuse my password for privileged tasks. There's a whole bunch of information available through this interface. You can see the utilization of your server. You can restart the server or shut it down through this web interface. But what I want to do is go to storage and I want to click on volume groups. I want to select this first volume and then I want to shrink it or grow it. Notice we're told that there's not enough disk space at the moment. Now Cisco have documentation showing you this, and the reason for this is I need to expand the virtual machine settings first. So on the CLI of the server, I'm going to shut it down. And what I want to do here is go to the settings of my virtual machine. I'm using Fusion here, VMware Fusion. If you're using VMware Player or VMware Workstation, the interface will be slightly different, but the same principle applies. I'm going to select my hard drive and I'm going to make this bigger. So let's make it 100 gig. That's okay in my example because I'm not going to pre-allocate disk space. I'm going to allow this to grow as necessary. So I'll click Apply. VMware is expanding the virtual disk at this point. Please note that this won't work if you've got a snapshot. In the Cisco documentation, they show you two methods how to do this. You can add a additional hard drive or virtual disk, or you can expand the virtual disk. In my example, I've simply expanded it. So notice it's now 100 gig. That's possible because I don't have any snapshots on my server. So while that's booting up, Cisco show you through their documentation that there's two methods. You can add a second virtual disk, or you can expand an existing virtual disk. This will only work if you don't have snapshots. You'll have to delete your snapshots to get this to work. Okay, so my VIRL server has booted up. IP address once again is 10.0.0.125. I'll reconnect back on port 9090. Make sure that you select that option, you reuse my credentials. Under storage once again, I'm going to click volume groups. I'm going to click on plus to add physical volumes, and I'm going to select this 84 gig unpartitioned space and click add. So notice I've got two physical volumes. I'm going to click on this first one of 14.5 gig and click grow to grow it. So I'm just going to grow it to the maximum that it allows and click grow. And notice I now have 98.5 gig of space. So back on the user interface, notice I have 98.48 gig of space. Make sure that you expand your volume or add a second virtual disk before you upload that QCOW2 file to the VIRL server. Make sure that you expand your disk space, otherwise you're going to have problems. Now through VMware, once again, I'm not pre-allocating all this disk space. I'm letting the volume dynamically grow as I need space. But obviously you need enough disk space on your physical hard drive on your computer to support this. And this will grow obviously depending on the number of virtual machines that you add to your topology. So now I can upload the file to the VIRL server using SCP. The next step is to upload the QCOW2 file to Cisco VIRL or CML. And to do that, we're going to use secure copy. First thing you need to know is the IP address of your VIRL server or CML server. Mine is 10.0.0.125. So I could browse to 10.0.0.125, and you need to use the login name that you use for the web browser. So in my example, the username is admin, password is Cisco123. So you notice I'm using an admin account here, IP address of the VIRL server or CML server. Important, make sure that you put this colon at the end. You must have that at the end of this command. So the command is once again SCP, name of the QCOW2 file, so win10.qcow2, username used to log into the GUI of CML, IP address of the CML server, and a colon at the end. So on Windows, that's the command that we're going to use. I'm going to open up another terminal. You could just use the previous terminal that you were using for doing the conversion. But just to show you the full process, once again, I'm going to go to my downloads directory. So cd downloads. I need to go to my MS Edge directory. So MS Edge. I'll clear the screen. dir shows me that I've got this QCOW2 file in that directory. So I'll clear the screen again. The command to do the copy is that. In this example, I'm running CML or VIRL2 on my Mac. So it's going to be copying from that Windows computer to VIRL on my Mac. So I'll paste the command in and press enter to do the copy. Now I'm told that the authenticity of the host can't be established. Am I happy to accept that public key? In my example, I am. So type yes. I need to put my password in, which is Cisco123 in this example. And as you can see there, it's starting to copy the file to CML. Now, it's quite slow here. I'm traveling, so internet speeds are not very good. The wireless isn't very good, but that's copying the file from the Windows computer to my Mac. On a Mac, it would be very similar. So I'll go to my downloads directory. And if I ls and just grep for cow, as you can see, I've got a whole bunch of QCOW2 files here, but this is the one that I would want to upload to my VIRL server. It's exactly the same command. So SCP, name of file, and notice I get the same prompt. Let's make this a bit smaller. So there's the command once again. I'm told that the authenticity can't be verified. I'm going to say yes, put my password in, and notice the file is now copying to the VIRL server locally. So you could copy it either from Windows, as I've demonstrated, or from a Mac. Now the process on a Mac is very, very similar. Same kind of command. You obviously only have to copy the file once. You're not going to copy it from Windows and from a Mac to the same server. You only copy it once. Okay, so once the file has uploaded to CML, we need to create what's called a node and image definition. VIRL is running locally with this IP address. Now my browser cached the credentials, so I'm auto-logged in, but you need to log in and then go to Tools, and you have to go to Node and Image Definitions. you're going to have to manage uploaded images and create a node definition. Now, before I create a new image definition, I'm going to scroll down this page and I'm going to create a new node definition. So just to show you the full process, under Tools, Node and Image Definitions, scroll down and you'll see this option, Create New Node Definition. We can see other nodes here such as CSR 1000Vs, iOS XRs, etc. But let's create a new node definition. So I'll call this Windows 10 as an example. Description will be Windows 10. The nature of this device will be a server. It's not a router or a switch. Under user interface, I'll leave everything at default, but this is where it becomes important. Under Linux native simulation, I'm going to use KVM, and I'm going to use server as my simulation driver. Disk driver, I'm going to specify SATA or SATA if you prefer. How much memory do you want to allocate to your VM? I'm going to allocate 2 gig and 2 CPUs. Now you might want to allocate more than that, but that's okay to get us started. Network driver is going to be E1000. Data disk size I'm going to leave at the default. Boot disk size I'm going to specify 64 gig. Now again, you're going to need to increase the disk space of your server to be able to boot a disk of this size. Video model is going to be Cirrus VGA. Amount of video memory is going to be 16 meg. Scrolling down on interfaces, this device does not have a loopback interface. I'm going to create 1 serial port and I'm going to give it 2 Ethernet interfaces. So the first Ethernet interface is going to be Ethernet 0. Second Ethernet interface is going to be Ethernet 1. Boot time I'm going to set to 300 seconds. That's not actually required, but I'll leave it in the configuration. I won't enable PyATS. Configuration generator I'll set to server. And I'll click Create to create the node definition. I forgot to set the user interface prefix. I'll specify that as Windows. Icon is going to be a host. A label is going to be Windows. You could set these to whatever you wanted them to be. And then I'll click Create to create the node. So the node definition has been created. So if I go back to Node and Image Definitions, scrolling down, you can see I've got a Windows 10 node created. So now, click on Manage Uploaded Images. This is the uploaded file. You can upload files through the GUI. That works well if they're small files. Notice they have to be QCOW or QCOW2 in format. But if you're going to upload a large image, rather use SCP. I'm going to create the node definition now, and I'm going to call it Windows 10. Label will be Windows 10, description is Windows 10. The disk image is Win10, QCOW, and the node definition that I'm going to use is Windows. And I'm going to click Create Image Definition. And as you can see, the image definition has been created. So now, if I go to Lab Manager, and create a new lab, what you'll notice is I have a Windows icon and I can drag that and make it part of my topology. So I could connect that to an iOS V layer 2 switch. So Ethernet 0, first Ethernet interface is going to be connected to the first Ethernet interface on the switch. I will add an external connector. And what I'll do on this device is set it as a bridge. So I'm going to bridge the VIRL or CML network to my physical network. I'll just zoom in here a bit more. So I'll connect that switch to the external connector. And there you go. I've added a Windows device to my VIRL topology. I'll also change the name of this Windows computer. So let's call it Windows 10 rather than Windows 0. Under interfaces, we can see that Ethernet 0 is connected to the switch. Other interfaces not currently connected. Under simulate, this is where I want to start it up. We can see that the image definition is Windows 10. I can see the RAM and CPUs. You could change that if you wanted to. You could also change the storage, but notice it's inherited everything from our node definitions. I'll click on the lab topology and then click Simulate Start Lab. And as you can see, my different devices are booting up. I'll click on the Windows device and go to VNC, open VNC. And as you can see now, Windows is booting. Now it may take it a while to boot up initially, but there you go. I've got a Windows computer and I can log in with my password. Again, it may be slow initially. All depends on how much RAM and CPU you've allocated to this. In my example, it's only got 2 gig of RAM, 2 CPUs. You can see the CPU is running at almost 100%. Boot size is 64 gig. If you allocate more RAM to this virtual machine, it'll run better. Okay, so I'll start up a CMD prompt. I'm not sure if you can hear my Mac, but the CPU is going crazy at the moment. I found that this started up really slowly. It was very slow initially, but then got better later on. Again, you may want to allocate more CPUs and more RAM to the virtual machine. Okay, so I've got a command prompt open, ipconfig. Shows me that this Windows computer has an IP address, and hopefully I'll be able to ping google.com, which I can in my little network. So I'm pinging google.com through a Cisco IOS switch. If I look at the console of that switch, show version, shows me that this is a Cisco IOS V switch. Make this a bit bigger. So IOS V. Now I did zoom on my browser, and that makes the interface a bit smaller. But as you can see, I have got access to a Cisco switch, and I have got access to a Windows machine. I'm using VNC in this example. So again, IP address is 10.0.0.120. I'll open up Control Panel. Go to Network and Internet, Network and Sharing Center. I'll go to my Windows Defender firewall, and what I'll do in this example is simply turn it off for the moment to do a test. So I'll turn off my firewall. I'm told that the firewall is disabled. So on my Mac, can I ping 10.0.0.120, which is the IP address of this Windows computer? And notice I can. I am pinging the Windows computer through the bridged network. So I'm pinging from outside through this external connector, which is bridged to my local network. Notice it's bridged through the Cisco switch to the Windows computer. I'll open a remote desktop application. 10.0.0.120. I'm going to set this as 120 by 80. Click OK. Double click on that. It's not currently working. So back on my Windows computer, VNC. Go back to Control Panel. Allow remote access to this computer. And click Apply. So back on my Mac, can I get access to that computer? I'm asked to enter my username. Now I can't remember the default user account. On the desktop it tells me users, i.e. user with password like that. So i.e. user password like that. And notice it's configuring remote PC. On the VNC session, it's gone black because I'm RDPing to this host. You can see the computer is now locked, and I'm now controlling that through my Mac. I'm now connected using remote desktop from my Mac to the Windows computer running within CML or Cisco VIRL. ipconfig once again shows me the IP address. I'm connecting to that device through the bridged interface, through the Cisco switch, and controlling the Windows 10 computer. Now, once again, there are a lot of steps here, a lot of things that you need to do to make this work. It's not as simple a process as you would get, say, on GNS3, but it's not too bad. You've got to basically convert your vmdk to a QCOW2 file and then upload it, and then create your node and image definitions, and then it becomes available to be added to your topologies. Okay, so really long video. Hopefully you've learned something. If you don't mind, please like this video. Please subscribe to my YouTube channel, and please click on the bell to get notifications. I'm David Bombal. I want to wish you all the very best.